Okay, we're back. We're doing Math 200. This is the note packet for Chapter 4, and we're looking at 4.7. This is graphing systems of linear inequalities. So that's where you're shading half planes, but we're only going to shade what they have in common. So let's take a look at, oh, that should be a 1. And not a 3. Okay, so graph the solution of the system. So they have 3x plus y is less than 9, and they have 2x plus 5y is greater than or equal to 10. And they want us to graph that system of linear equations on the same plane. So let's do that. First, to graph it, we have to solve for y. So minus 3x, minus 3x. So we got y is less than negative 3x plus 9. Let's grab the slope. That's negative 3 over 1. Let's grab the starting point. That's 9. That's not a grand starting point, 0,9. So I'm going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I think if you look at my notes, I just added the lines on there so we could start with 9. All right, so there's 9, and now what do I do from that? This tells me to go down 3, because it's negative, and then always, the bottom is always to the right, 1. So down 1, 2, 3, to the right 1. And now, is it a solid or a dashed line? Well, it's a dashed line because greater than or less than is a boundary, not an inclusive boundary. So that's a dashed line. Now, here comes the part that some people are very intuitive. They're like, oh, it's less than, so it's down here. And other people are like, I don't know what side it is. So whichever way you are, you can always test a test point. And 0, 0 is always super easy to test. I'm testing 0, 0, because then I put 0 in for that, 0 in for that. So 0 is less than negative 3 times 0 plus 9. Is 0 less than 9? Yes, that works, or it's true. And so if this point works, all the points on this side of this line work. But I'm not going to go crazy shading it. I'm just going to kind of do a little snaky like this on the side of the line. That means I'm going to shade that side of the line, but I'm not going to go crazy shading that side of the line because I got to do another line. This is a system of equations. So this one, let's do this one. We got to solve it for y. Minus 2x, 5y is greater than or equal to negative 2x plus 10. And then divide by 5. And then y is greater than or equal to negative 2/5 x plus 2. I got a slope of negative 2/5. I've got b of 2, or 0, 2. So that's my starting point on the y-axis, the y-intercept, all right? So I go to 2, put a dot, and from that dot, this is telling me down 2 and to the right 5. So if it's negative, always attach it to the top, and that means up or down, positive up, negative down. And so down 2, 1, 2, and then to the right 5. 1, 2, 3, 4, 5. And now this should be a solid line because it's greater than or equal to, less than or equal to. There's my solid line. Now, forget about all of the stuff that's here in, the dash line and all that. Just think of the blue line here. And now should I shade above or below? Well, it is greater than, so it's very likely going to be up here, but just in case, I'll test 0, 0. I think it's going to fail, but let's see. 0 that, 0 that, so 0 greater than negative 2/5 times 0 plus 2. It's saying 0 is greater than 2. 0 is not greater or equal to 2, so it fails. So if this point on the side of the blue line fails, all of the points on this side fail. All the points that work are on this side. And so now, this is what I need you to do. You're just going to graph the parts where they overlap. See where the two little snakes cross. So just in there. We just want their intersection. All right? So those are all the points that would work in both inequalities. Any points that you pick off of that shaded area would work in both inequalities. All right? And then the last one on the note packet here, 4.7, is a weird one, of course, a weird one, right? Again, I'm not going to put a weird one of these on the test. But this one asks, where do they intersect? But if we look at them, let's take a look. On the upside, they're both already solved for y. But hopefully something about these two lines is jumping out at you right away. So this one, I'm doing black, that is a slope of 2 over 1 and a starting point of positive 4, right? So 0, 4. So y-intercept, 1, 2, 3, 4, always on the y-axis. There's their dot, up 2 over 1, dash line. Test 0, 0 is 0, 0 gonna work. It's greater than, so I think it's up here, but I'm not sure. If you're not sure, you test the point. Test 0, 0, 0 is always the easiest one to put in. That's why we always test that point. 0 is greater than 4, fails. That's not true. 0 is not greater than 4. So this point fails, so all the points on this side fail. So I would do above the line, but I'm not gonna go crazy shading it. This one, slope of 2 over 1 and a starting point of -2. Oh, I'll do that one in blue. Sorry. I'll do this one in blue. And so 0, -2 is my starting point. To go down to -2, I put a dot. I go up 2 and over 1, I put a dot. I do a dashed line again. And then I think less than is going to be down here, but I'm not positive, so I'll test 0, 0. I think it's going to fail. 0 is less than 2 times 0 minus 2. 0 is less than -2. Nope, 0 is greater than -2. So our test point 0, 0 failed, which means all the points on this side of the line fail, but all the points that work are down here. Well, now look at what happens. This has a slope of 2. That has a slope of 2. Both with different starting points. Those are parallel lines. They're never going to cross, which means never the two shall meet. This shaded area shall never overlap with this shaded area because there's always going to be this uniform distance between them with our dashed lines. So that one has no common area. There's basically no solution for that one. All right. And that is kind of a weird problem. Okay, so that was it for chapter 4. Study, study, study. Look over the review.